Hi all, today we'll be covering Kubernetes, and in this playlist we'll be covering from intro to the advanced level of Kubernetes like ingress, RBAC, liveness and resource management. Let's get started with the introduction. Coming to the prerequisites of Kubernetes. Yes, there is prerequisites. You should be knowing Docker and Docker Compose. Docker knowledge is a must, whereas Docker Compose is optional. Docker Compose is again an orchestration tool, just like Kubernetes. So, if you know Docker Compose, you can easily correlate what's happening in Kubernetes. And Docker knowledge is a must. You should know how to run a container, how to start a container, or how to stop a container, how to build a container. Yeah. So coming to what is Kubernetes or K8s. So Kubernetes is a container orchestration tool. And so next question is, what is container orchestration tool? So it's a tool that is used to manage, scale and maintain containerized applications. So again, Docker Compose is another example of a orchestration tool. So how is it different from Docker and Docker Compose? The thing is, Docker Compose or Docker is meant for a single host deployment or a simple deployment, whereas Kubernetes is meant for multi-node real-world applications. Let's say an enterprise is deploying a service, they will surely go with Kubernetes instead of Docker. Another differentiating factor is K8s is internally having master and worker nodes. It supports RBAC. This is role-based access control. DRA is disaster recovery. HA is high availability, replicas, and load balancing. All these enterprise features are supported in K8s, whereas it's not supported in Docker Compose. And most importantly, you can easily remember like all the scaled production, all the enterprise production settings will be going with Kubernetes, and all the internal deployments can go with the Docker Compose. Coming to the architecture of K8s, this is a very simple architecture of K8s. So we have a client piece as well as we have a server piece. Server piece is internally having control plane and data plane. So this is the client piece and we have a server piece. Need not look into what's going inside. You have the controller, server and the scheduler. So proxy, kubelet, all these things are there in the server side, but you should be remembering like there is a client piece and a server piece. I mean, there is no point. I mean, there is advantages of understanding what goes into it, but that's out of scope for this session. So there is a client piece and there is a server piece. So all you need to know now is K8s, there is a K8s server and there is a K8s client. And the K8s server spins up services or Docker instances on demand and maintains the state of all worker nodes. That's one. And K8s client is also called Kubectl or kubectl. So kubectl client allows us to interact with the server. So you have the client piece, which is the kubectl, and that interacts with the kube server, and kube server internally maintains all the state of the worker nodes, all the states of the running nodes. So additional fun facts. So it is open sourced. Again, Kubernetes is maintained by Google. So cube and there is 8 letters, that's why K8s. So it's much better than Docker Compose deployment, even though there is an overhead. When you are studying Docker, you might not understand the need for Kubernetes. Once you are into any production scale setting and understand how Kubernetes works, you'll never go back to Docker Compose. The first option that you'll prefer for sure is Kubernetes. Hi, in the next section we'll be covering installation. So there are many implementations of K8s. There are full-blown K8s services like EKS, GKE, Azure Kube services. So EKS stands for Elastic Kubernetes Service, and GKE is the Google's Kubernetes engine, and K3S, K3D, RK2, Kind, and Minikube. My personal favorite is K3s and K3d. These are meant for single host deployment of Kubernetes, and even within these two, my personal favorite is K3d. K3d is K3s on a Docker container. So these are the three softwares that must be installed. One is Docker, and then the K3d, which is a server piece, and we need to install Kubectl, which is a client piece. So go to the Docker engine, and you need to install the Docker engine, and you need to select the operating system. Mine is Mac OS, so I can just download the Docker desktop for Mac with Apple Silicon, and it installs the DMG file on my machine. Same goes for the Windows, and again Windows will have a desktop application, so you can just download it and run it. So that's with the installation of Docker engine. So the next piece that we need to install is the K3d. K3d installation is fairly simple. All you need to do is just run this one single command, and it installs the K3d for you, the server Kubernetes server for you. It's fairly simple. I mean, all you need to do is just run this single command, and it installs the entire Kubernetes server for you. So coming to the next piece, we need to install the client piece also, which is a Kubectl. So just go to the link. Again, select your operating system, which is a Mac OS, and you need to run this single command that installs the client piece, the Kubectl piece. So it's fairly straightforward. You can see installing server is a single command, installing client is a single command. That makes your journey to Kubernetes much easier. That's it with the installation, and in next session we'll be covering pods, which is a fundamental unit of Kubernetes engine. Before getting started with the next section of pods, we need to run few commands to configure the K3d environment. So we'll go to terminal, and let me increase the size. And the first command that we need to run to configure K3d is to create the cluster. So run this command, and it creates the cluster, my cluster. You can see it installs all the containers that are required for the K8s environment. So it installs the server load balancer, server tools, it configures the DNS. So it created the cluster. So that's one, and now we need to check whether everything is running properly. So get pods -a, and you can see these containers are getting created, and we can run it again to see it's still in the creation phase. It takes around 1 minute for the cluster to get configured properly, and just keep on running. Get pods -a, see some changed into the running state, and once every container is in completed or running state, we can know now all the containers are in the running or the completed phase status, so we can be sure that the K8 server is configured properly. So that's one. Next thing, get back to the pods. So the K8 server and the client piece is configured properly now. So what are pods? So pods are almost similar to the containers, but pods can contain multiple containers. That's the difference. The functionality of pods and containers are similar, but pods can contain multiple containers. Generally, the additional container or the sidecar or the init container are used for logging and initialization purpose. Example is a fluent bit container with the server container for logging. Conceptually, it serves the same purpose, and it is same and it serves the same function. Let's get to the meat of Kubernetes, how to create one pod. So here is an example of converting Docker command to the pods.yaml file. So this is a sample command, Docker command on how to start an Nginx container. So we'll be replicating the same in Kubernetes.yaml file or the pods.yaml file. So unlike Docker commands, you are not supposed to by heart the template of Kubernetes file. If you by heart it, you are supposed to make mistakes. So what you are supposed to do is you need to search for KTS pods.yaml file, and it gives you the base template, and you're supposed to make modification on the base template instead of by hearting yourself and making mistakes. When you're copying, all you need to look for is the specific sections of the template file, like the kind, what is a container name, what is the image that we are going to provide. So we'll be copying it. You need to copy it, and we'll come to the terminal. So we'll start by creating a folder KTS and cd KTS. Okay, so KTS okay. Okay, I should be running it and fine. So we'll go to the pods.yaml file. We'll create a pods.yaml file, and we will paste the content of the YAML file. Let's get to the Notion. So here we are trying to pull the Nginx latest image. So we'll change the image to latest. We'll pull the latest image, and then we'll expose the port 80, similar to the Docker command, and that's it. We have to look for the kind is pod, so that makes sense, and we are providing the name Nginx. So we'll save this file and ls, and we have this pods.yaml file. So how do you create the pod? So whenever you have a YAML file, the command is same in Kubernetes. So it is kubectl apply -f pods.yaml file. So you do that, and the pods get created. So let's check whether the pod is created or not. Get pods, and you can see the Nginx is running. Now let's try to ping the Nginx server. So localhost 80, bang, you are unable to connect to the pod. Unlike in Docker, unless you provide a networking to the pod, you won't be able to connect it from the localhost. So but we need to verify, right, whether it is running or not. So let's do one thing, kubectl get pods, and you can see Nginx is running. So how do we check? Similar to the docker exec command, we have the kubectl command. So kubectl ti, the name of the pod is Nginx, and you have to run bash. You can see I got into the pod, the root pod. Okay, so ls, now I can run localhost 80. Now you can see it is serving the Nginx web page. So that means Nginx is running, everything is working fine, but we haven't connected the network to the pod yet to access it from outside networks. Exit. So we are outside of the pod. Now let's see how to delete the pod. So kubectl delete pod, and it is Nginx. So you can see it deleted the Nginx pod. And let me see. So what else is there? So further rates, you can read more about pods in this link. I'll share this HTML file or the PDF of this presentation later. In the last section, you might have seen me entering a lot of kubectl or the kubectl commands. You might find it difficult to follow it. So, I'll be explaining what kubectl does. So, kubectl is a client that interacts with the K8s server. So, the most common kubectl commands that we use are the kubectl get, delete, describe, logs, and exec. It's good that you by heart or understand what this commands does, and one important one is apply -f and the file name .yaml file. So kubectl get is used to collect all the resources. We'll come at a later stage what these resources are. So delete resource, whenever you are deleting, you need to specify the resource and you need to specify the resource name, as well as when you are trying to describe something, you need to specify the resource and resource name. And when it comes to logs and exec, you just need to provide the resource name. So resource name is nginx, and resource are pods, services, or deployments. So there are a lot of resources that are available in Kubernetes. So when it comes to get, you need to specify the resource type as a whole, like pod, get pods. So let's look what all resources are available. So the most important resources are pods, deployment, replica set, service, ingress. You can read more about this later, else this video will be way longer. So most important one is pod, most important one is deployment, services, ingress. Other common resources include config map, secrets, persistent volume claim, job, cron jobs, stateful set, daemon set. So these are the available resources. So let's construct the command. So let's say if you want to get the pod, kubectl get pods. Let's say you want to delete something, delete a pod, kubectl delete pod. Okay, let me add it here, that will be better. So it will be like kubectl get pods. Okay, there will be additional parameters also that you can learn on the go. Let's say if you want to delete something, so kubectl delete pods, or delete pod, or delete pods and nginx, the resource name. Okay, let me show you the real example. Why to type it here? So kubectl. Okay, let's start with the get. Okay, let me bring up. Okay, ls and clear. So I'll apply. It'll start from the base. So let's see, kubectl apply -f and the file name. So applying the file pods.yaml file. So you can see it created the container. So we covered the apply -f. Delete. Okay. So kubectl get the resource. So resource includes pod. So kubectl get pod. You can see it shows you the pod names. If you want additional details, I mean all the pods that are running, then you should give the -a parameter. If you are not providing any parameter, it shows all the pods that are running on the default namespace. You can look into namespaces in a separate video, some other YouTube video. You can look for the namespaces and all. It makes the things complicated. Not complicated, it's a, what would I say, logical separation of Kubernetes deployments. So that's a simple definition of namespace, logical separation of Kubernetes deployments. So let's say if you want to see something that is specific to the specific namespace, the containers that are running to the that are running in the specific namespace, let's say I'm giving default, it shows okay the ones that are running in the default namespace. Let's say if I just give, I want the pods that are running in the kube system namespace, it shows the container the pods that are running in the kube system namespace. So for now you just need to remember get, when you're using get you need to specify the resource. So another resource that we have is deployment. Let's see whether we have any deployments now. Deployment, you can see there is no resources available because we haven't created any deployments till now. So get is clear, right? Now let's delete it at the end. Okay, now let's see how to describe something, describe the pod. So Kubectl describe pod nginx. You can see it gave a lot of details of the nginx pod, when it was created, when it was started, what image that we are using, or which ports it is running, which port it is exposing to the host port, so what volumes it is using. So a lot of information, and the most important piece is it gives you this logs. Let's say some pod is having trouble starting up, so how you debug is through the describe. So you run the describe pod name, and it shows you events, what all happened. If something is failing, it will show the reason why it is failing, why it is unable to pull, whether it's some network issue or something. So describe is pretty useful for debugging. So again, Kubectl describe, resource, and resource name. That's how we provide it. The next thing is you have to get the logs. So similar to Kubernetes, similar to Docker. So Kubectl logs -f, and you provide the -f. If you're familiar, it's just for following, it's not required. So you need to provide the pod name nginx. You can see it gives you the, let me clear it. Okay, Kubectl logs and the resource name. Resource name is nginx. So it gives you the logs from the nginx pod. So you can see it started running. So that's with the logs. And the next thing is exec. So exec, again similar to Docker, Kubectl exec ti, and you need to run for nginx and bash. You can see I'm inside the container. Now I can execute commands. I logged into the container as a root user. So that's how you run the exec. You can exit from it. And next, final one is delete. Delete again comes in the format Kubectl delete resource and resource name, similar to exec. Delete pod nginx, and it deleted the pod nginx. Similarly, you can delete services deployments. We'll come to what is deployments and services later. That's it. And if you see, the reason why we just provide exec and logs to a resource name, it's because it's specific to a resource. Let's say if you are running, if you want to exec, we specifically need to exec into a pod. So there's no point in providing the resource type here. Whereas delete and describe, the same logic goes through, what you have to delete multiple types of resources with same name. So it is good to have this resource tag attached to it. So just remember these 5-6 commands and you are 90% good to go with Kubectl management or the K8 server management. Get, delete, describe, logs, exec, and apply. If you know this 3 plus 3 6 commands, you are good to go. And don't by heart the template for creating pods or the deployment files. So this is the end of day one. In next session we'll be going with deployments. Till now we haven't seen any real use of having Kubernetes. We just created pod, but the same thing you can do in container. Why to have all the overhead? So as we mentioned here, the deployment, when it comes to deployment, we have this additional functionality like high availability, managing replicas, disaster recovery. So we'll be seeing the real fruits of Kubernetes in the next day. Yeah, thank you. Yeah, just learn this 6 commands and you're good to go. Thank you. Yeah, bye. Hi all, welcome to the day 2. In day 2 we will be covering deployments, services or the load balancer, volumes, config map and secrets. Coming to deployments, so deployment provides a mechanism for auto healing and state management. So what do you mean by auto healing? Let's say one of the container or the pod goes down due to some error. So it should restart automatically. The auto healing provides that feature. It auto restarts the container if it goes down. Next is state management. State management makes sure that, let's say I want 5 instances of Nginx running at a time. So I specify like I need 5 replicas of Nginx. So the state management automatically ensures that 5 are running at a time. Let's say if one goes down, it automatically restarts another one and makes sure that the state is 5. So deployment internally uses replica sets. Replica set is a type of resource and that maintains the expected state. In replica set, we specify I need 5 instances of Nginx, so it always maintains that state. Let's say 2 goes down, it automatically restarts another 2 instances of Nginx. Next is deployments can contain multiple pods. We'll go through a deployment.yaml file. As usual, it's better to go with the official documentation of Kubernetes instead of by hearting the template of deployments. So Kubernetes deployment, search for it, you get the base template here. So fine, I copied it and let's go to the terminal. Clear and I have tested it before, so Kubectl delete -f and deployments.yaml file. Okay, so more of deployments. Okay, I'll create a fresh file, deployments.yaml, and I'll paste the contents of it. So here I'll set the number. So we'll go through the important parameters that are present in the deployment. One is the kind I specify as deployment, but in this file we'll start from the bottom. So deployment spec is having a parameter template, and in that template I'm specifying the label of template as app nginx. You can see template metadata label as app nginx. So the template name will be app nginx, and the template will be containing the containers nginx, and the image will be nginx latest. And pods 8 port 80. Okay, so deployment is internally having a templates property, and we are setting the label of template as app nginx, and the template will contain container nginx latest. Okay, now we'll move up a little, one level up in the YAML file. So deployment spec is having a property called as replicas. Here I specify I need 5 replicas of template matching the label app nginx. match labels. So match label looks for the template containing the label app nginx. So here match label is same as the template name. So this both will get matched, and 5 instances of this template gets created. Most important thing is the template label and match label should be same. If they are not same, then it won't be able to create 5 replicas the template. Okay, let me save it, and so kubectl apply -f deployment.yaml file. So it created the deployment. So kubectl get deployments. Now we'll run that. You can see there is an nginx deployment. Out of 5 are ready, 5 are available. Okay, kubectl and get pods. You can see 5 deployments of nginx are running. It's awesome, right? I mean, with one command you created 5 instances. Let's say if you want 100, you just change the replica set to 100. Now let's look at the replica set to kubectl get replica set, or rs. You can see there is an nginx deployment. The desired is 5, current we have 5, ready is 5. Okay, now let's try deleting a pod and see whether auto healing is really working or state management is really working. So let me delete the 2df8h pod. So kubectl delete pod, and I specify the name kubectl delete pod. And let me paste it here. So I'll be deleting the pod. Now let me check. So it restarts another container. You can see, right? It deleted, but it restarted another container. So that is the state management. You can see now all 5 are running again. So how do I delete the pod? You can't individually delete the pod. All you can do is you can delete the deployment. So we have the pods, and I deleted every pod. Let's see how I can delete the deployment. Delete deployment and deployment.yaml, or delete -f deployment.yaml. So if I do that, it deletes the deployment. Now if we check the pod, if we delete the deployment, it automatically removes the pods also. So get pods, you can see there are no pods remaining. It removed all the pods too. So that's it with the deployment. Yeah, we'll see about services in the next section, where we add networking to the deployment. Now we will go through the next section, service or load balancer. So load balancer or service is used to provide networking to the deployment, or acts as load balancer to the deployments. Service is used to add network to the deployed pods. In real definition, it's an abstraction to help you expose group of pods or deployments over a network. So service type. So coming to service type, we have 3 types of services. One is cluster IP, node pod, and load balancer. So cluster IP is a default service type. So primarily used for internal communication within the cluster. Let's say you want to communicate, you want to establish communication between pods, then you go for the cluster IP. Pods within a cluster, then you go for the cluster IP mode of networking. Only accessible within the cluster network. You won't be able to access it outside of the cluster network. You basically can't access it from the local host or from outside the local host. So Coming to IP assignment, it allocates a virtual IP within the cluster. You won't get external facing IP address when you're going with the cluster IP. So services that are only consumed by other services within the cluster. This is most important. Let's say there is a service that requests connection to database. Then the connection between the database might be exposing a cluster IP so that it can be only accessible within the cluster, not from outside. But at the same time, it can be accessed by the pod that is present in the cluster. Internal load balancing. So that's another use case of cluster IP. So when you are seeing cluster IP, this should be your primary thought. Like it's used for internal communication within the cluster or port to port communication. So cluster IP will be like port to port communication, not for external communication. Port to port internal communication. This should be the thought that come into your mind. Port to port internal communication. Node port exposes nodes in the cluster. So this is used when you want to access the service within the cluster as well as from outside the cluster through a port. So allocate static port on each node. And so the use case of node port is services that needs to be accessed from outside the cluster but do not require a public IP address. So it's an example of simple load balancing. So you will get an internal IP address, but you won't be getting a public IP address, but you will be able to access it from outside the cluster. In our demos, we'll be going with node port because this is local host access. So whenever you're seeing node port, the first thing that should come into your mind is local host access, and node port is used for testing primarily. So and the services can be accessed from outside, but most likely for testing purposes. And next thing is load balancing. So load balancing is an enterprise setting of services. So the purpose is to expose service to network or expose service to internet or a corporate network. IP assignment, when it comes to IP, creates a load balancer in the cloud provider's infrastructure and assigns a public IP. In load balancer setting, you will get a public IP and you can access the service from anywhere in the world. So the use case is services that need to be publicly accessible. So let's say we have Netflix.com, so it will hit the load balancer service first. Then the request gets internally routed to the deployment or the pod. So advanced load balancing features like affinity, session affinity, health checks. So load balancer is an advanced setting, and you will be using load balancer in enterprise grade settings. So to show you a demo of the services, so we will be going with node port because we can access it from the node port or from the local host, and this is mostly used for the testing purpose. Or simple deployment, you go for the node port. This is not the preferred way of deployment due to security concerns. Still, for testing, this is a variant of services in Kubernetes. So we'll, as usual, we'll go and search for the services in Kubernetes. And so services, we'll search for service.yaml example in Kubernetes, and we will get service documentation. So here you go, you copy the first available template, copy it, come back to the terminal. So terminal will create a service.yaml file. Paste it here. So here we'll go through the important parameters. One is a kind is of service, and you specify the name as my service. Here you are providing a selector. You have seen the selector, right? This selector should be same as the template label that you provided in deployment. So let me do one thing. Let me cat deployment.yaml file. So here the template label is app nginx. So this should be matching to the service selector. So let me deploy this deployment -f deployments.yaml. So it created the deployment. This is the label app nginx vi, and the name is service.yaml. Oh, okay, I didn't create the file. Service.yaml, copy it, paste. So kind is service, name of service is my service, and let me change the selector. Selector is app nginx, and I'm specifying protocol TCP 80, and target protocol is, let me check one more second, app nginx. This label should match service.yaml selector app nginx. So that is same. Next thing, what we need is a node port. So we'll be searching for node port. We can see node port example. We need to copy this field. What you need to do additionally is, okay, instead of this, let me remove the service.yaml. vi service.yaml. Let me copy this. So service, the selector is app nginx. The type of service is node port. So app nginx. The port that the container is running is 80. The target port is 80, and the port that you want to expose. The port that you want to expose to the local host is provided in node port. So it will be exposing to the port 30,007, and it should be in the range of 30,000 to 32,767. So you save it. So we'll again go through the service.yaml file. Kind is service. You provide the name of service. You specify the type of service as node port, which is localhost, nothing but localhost. Selector as app nginx. This should be same as the one that is present in the deployment.yaml file, and you specify which port it should be looking for and which port it should target to, and the node port to which it should be accessible from the localhost. So here the localhost is accessible from 30,007. So let's save it, and kubectl apply -f service.yaml file. You start the service. So kubectl get service can be also called as svc. So you can see there is my service, and the node is of type node port, and the cluster IP is 10.43.9.175, and it is exposing the port 30,007 to the local host. Now we can see that the service is running on the port 80 and 30,007. Since we are running in K3D, you need to do an additional step, that is port forwarding. So let's do the port forwarding. This is a command to do the port forwarding. Here we are forwarding my service running on port 80 to 8082. So if you do this step, the ports whatever request is coming on port 8082 will be forwarded to port 80 inside the cluster. So let's paste it. So it's already forwarding now. Whatever comes to 8082 will be forwarded to 80 inside the cluster. So let me run localhost 8082. You can see it is serving the page nginx, and this is coming from the deployed service. So that's one, and let's stop it. Now let's see how to access nginx from another deployment or another service. So let's copy this. So I'll create one Ubuntu deployment. So ubuntu.yaml, and I'll paste the content here. So I'll create an Ubuntu deployment, Ubuntu container, and let kubectl apply -f and ubuntu.yaml. So it creates a ubuntu.yaml file, creates Ubuntu deployment. Now let's get into the Ubuntu pod. So you can see there is one Ubuntu pod. So let's get into it, exec into it. So exec ti Ubuntu deployment, and let me bash into it, Ubuntu deployment and bash. So clear. So once I do env, you can see my port information is already present inside or already injected into this container. My service pod, my service TCP protocol, my service load balancer address. So let's do one thing. Let's do curl of my service. Okay, curl is not installed on this container. So what we need to do is apt update. Wait, apt install curl -y. And now let me do curl my service. You can see it is able to connect to the nginx and retrieve the HTML file. So you can access other services from the deployments too. So all this works because of the internal load balancing that we mentioned before. That's it with the services. That's how you connect from one service to another service, or connect from one deployment, one port to another service. And this is how we do the port forwarding. Yeah, thank you. In this section we'll be covering config map. Config map is very useful and it is very simple also. So config map is an API object which is used to store non-confidential data in key value pairs. This is the most important term, non-confidential data in key value pairs. Basically it's a dictionary that can store non-confidential data. So pods can consume config maps as env variables or the environment variables. Config maps allow you to decouple environment specific configuration from the container images. Let's say you have a deployment file and you don't want to specify the database user, then a config map is a way to configure it at the runtime. Now let's see how to create one. So kubectl, you can see from literal, this is how you create the config map through CLI. So you need to provide this command kubectl create config map, some config map name, and you provide the key value pair from literal key value. Okay, so this is an example. Here the config map name is my config. So let's see, let's create this, and let me open the terminal and ls. So let me create the config map, created it. Now let's see, get cm. Let me see, you can see my config is there, my config map is there. And then if you want to see the content of config map, then you can specify get cm myconfig -o YAML. You can see what all are the data that is contained in the config map and when it was created. So we have two values, two key value pairs. One is database host, other one is database port. So that's how you can see the content of config map. We have seen at the end we will see how to create one from a file also. We can also edit config map. So kubectl edit config map and config map name. So my config, you can see I can add one more entry here, then we can access it outside. So like database URL MySQL. That's one way to do it. You can say the config map is edited now. Now let's run it again. You can see it's added and it's stored. Okay, so that's one. And next thing that we will cover is we can delete the config map. I'll show these two at the end. Loading it from a file and deleting it. Now let's use the config map that we created inside a deployment file or inside a container or inside a pod. So this is how we add. So we need to specify, I'm using an env, I'm loading an env, and the name of the env inside the container is database host, and I'm pulling the value from the config map key reference, and the name of my config map is myconfig, and the key that I'm trying to pull is database host. So internally it should have localhost as a env. So let's copy this piece and let's come to our Ubuntu image, Ubuntu container. So here I'll add let me align it properly. Since this is a YAML file, you need to align it properly. So we are good. So we will be able to access the database environment variable inside the container now. So let's save it. Kubectl get deployments. You can see Ubuntu deployment is already running, so I'll delete it. Delete deployment Ubuntu deployment. I deleted it. Let me start the deployment again. Apply -f Ubuntu deployment ubuntu.yaml. Now we can see the deployment is created. Let's check the ports. Get ports. We can see one is getting terminated but other is running now. So let's exec into it. So kubectl exec ti, and we need to specify the port name. Copy this guy, paste it here, and bash. Now let's do an env check, and well, you can see database host is injected as an environment variable to the container. So let me do database host. You can see localhost is here and localhost is here. That's how config map works. It's pretty simple but very useful. So that's how we inject config maps as an env to the container or the environment variable to the container. Now we have two things pending, right? How we load it from a file. So let's do one thing. Let me create another file, test.env, and okay, touch, let me do vi itself, vi test.env. Here I call prop1 property 1, okay, db user equal to sa, db password equal to test123. Let's have this file. Let's save this file at test.env. Now let's create a config map out of this test.env file. So create config map. Okay, my config, my test config, and I need to specify from file equal to test.env. From file equal to test.env. You can see config map is created. Let's kubectl get cm my test config and -no YAML. Now you can see it is having two variables, db user SA and db password 123. That's how you create config map from a file. So that's it, and let's see how to delete one. kubectl delete cm config map. My config map name is test config. Okay, that's it. So we deleted the config map also. Hope it is clear. Pretty simple but very useful, and we use it every day. In next session we'll be seeing secrets. It is exactly same as config map. Only difference is it can store sensitive information. In this section we'll be covering secrets, and secrets is exactly same as config map. The only difference is it can be used to store sensitive data such as passwords, token or a key. Now let's create a secret. You can see command is exactly same as the config map. The only difference is you need to specify the type of secret. So I'm just going with the generic secret here. You can read more about secrets later. So I'll just create a secret, and let me see, strong password. I'll be storing my database password in the secrets. So terminal, and let me do store the password. So secret is created. So now let's see get secrets. You can see there is one secret which is present. So let me try to get the data out of it. Okay, -no YAML. You can see the database password is there, but it is encoded in base64 format. But if you want real benefits of secret, then you want to use the HSM module or some other module that can provide you the additional security. So this is one example. Kubernetes IO/TLS can be used for storing the TLS certificates, the TLS keys. So accessing it inside the container is exactly same as a config map. The only difference is instead of config map key reference, you need to change it to secret key reference. So I won't be showing you how you can access. Okay, let me show you how you can access it inside a container. So vi ubuntu YAML, and we already have the name. Okay, let me add name, and name will be what? Database password. Let me paste it here. Let me align this properly. So it will be able to pull the secret from the secret container or the secret resource. So kubectl apply -f ubuntu YAML. Okay, there is some issue. There's a tab code. Okay, indentation. Okay, the set number 27 is having issue. Now let's start it. Okay, so it is deployed, clear, kubectl -f and ubuntu.yaml. It is deployed, and now let's exec into the pod, get pods, and kubectl exec ti and ubuntu container name, paste, and bash clear. Now let's check env, and you can see database password, my strong password. It is injected as environment variable from the secret. So echo dollar database password. You can see my strong password. This gets echoed. Yeah, so that's it with the secrets, and similar to config map, you can, but the only thing is you can't edit the secret. This command is not there. You can't edit a secret. If you want to edit the secret, then you need to delete it and create a new secret from it. Next thing is you can create a secret from a file. Generally these are used to load the TLS certificate or the TLS keys. And yeah, now let's see how to delete a secret. So kubectl get secrets, my secret, kubectl delete the secrets, kubectl delete secret, since it's a resource type is secrets, and resource name is my secrets, so it deleted the secret. That's it with the secrets. And yeah, this is helpful whenever you want to provide the credentials to database or user credential to the container. Then we use secrets.